Good evening, students. I am Mr. Arruldoss, Assistant Professor, Department of Mathematics, St.Joseph's College of Arts and Science, Cuddalore. Today we are going to see some theorems and definitions on finite extension for PG Mathematics students, semester 2. First we see a theorem. If L is a finite extension of K and if K is a finite extension of F, then prove that L is a finite extension of F. That is, L over F is equal to L over K into K over F. Proof. Before we start the proof, we just recall the definition of finite extension. A field K is said to be a finite extension of F, then it must satisfy two conditions. First one, F must be subset of K and F must be subfield of K. Now we go to the proof. Given that L is a finite extension of K, this means L is a L, the basis of L explicit over F. And also we can show that L is a finite extension of F, but we actually prove the sharper result and the one which is really the heart of the theorem, namely L over F is equal to L over K into K over F. Suppose that if L over K equal to M and K over F is equal to N, then V1 to Vm be a basis of L over K and W1 to Wn be a basis of K over F, where I is equal to 1 to M and J is equal to 1 to N. Now our claim is, what should be the basis of L over F? For that, first we must show that every element of L is a linear combination of F. So we demonstrate the dimension of L over F must be Mn elements which are linearly independent over F. Now we consider an element in L, that is T. Since every element in L is a linear combination of V1 to Vm with the coefficients in K, in particular T must be of the form K1 V1 plus K2 V2 plus and so on Km Vm, where the elements K1 to Km are all in K. However, every element in K is a linear combination of W1 to Wn with the coefficients in F on the other hand. Therefore, K1 can be written as F11 W1 plus and so on F1n Wn. And proceeding like this, our Ki will be Fi1 W1 plus and so on plus Fin Wn. And so Km equal to Fm1 W1 plus and so on Fmn Wn, where each Fij is in F. Substituting these expressions of K1 to Km in T, that is T equal to K1 V1 plus K2 V2 plus and so on Km Vm, we get T as T equal to F11 W1 plus and so on F11N Wn into V1 and so on Fm1 W1 plus and so on Fmn Wn into Vm. Multiplying this out using the distributive and associative laws, we get T equal to F11 V1 W1, F11 1N V1 Wn and so on Fij V8 Wj plus and so on Fmn Vm Wn. Since the Fij are in F, we get that T as a linear combination over F of the elements Vi, Wj. Therefore, the elements Vi, Wj will span all L over F, and so they fulfill the theorem. We still must show that the elements Va, Wj are linearly independent over F. To check their linearly independent condition, we take F11 V1 W1 plus and so on F1n V1 Wn and plus and so on Fij Va Wj plus Fmn Vm Wm equal to 0, where the Fij are in F. Our aim is to show that each Fij is equal to 0. Then again, reordering the equation, we get F11 W1 plus and so on F1n W1 n V1 plus and so on Fi1 W1 plus and so on Fin Wn into Vi plus and so on Fm1 W1 plus and so on Fmn Wn into Vm equal to 0. Since the Wi are in K and since K contains F, all the elements K1, K2 and so on Kn, where K1 equal to F1 1 W1 plus and so on F1n Wn are all in K. Now K1 V1 plus K2 V2 plus and so on Km Vm equal to 0, with the K1 to Km belongs to K. But by assumption V1 to Vm form a basis L over K, and in particular they are linearly independent over K. The net result of this is K1 equal to K2 equal to and so on Km equal to 0. Using the values of Ki, we get Fi1 W1 plus and so on Fin Wn equal to 0 for I is equal to 1 to n. But now we have to get the fact that Wi are linearly independent over F. This yields that each Fij equals 0. In other words, the Vi Wj are linearly independent over F. In this way, we get the result. Therefore, we have now succeeded in proving that Mn elements of Vi Wj form a basis of L over F. Therefore, L over F is equal to Mn, but we know M equal to L over K and N equal to K over F. Therefore, L over F is equal to L over K into K over F. Hence the theorem. Using the above theorem, we have a corollary, which means if L is a finite extension of F and K is a subfield of L which contains F, then prove that K over F divides L over F. For this, we consider the assumption that L over is finite and L over K is also finite. Since K is a subspace of L, K over F is finite. By the above theorem, we have L over F is equal to L over K into K over F. And from this, taking this K over F to the left hand side, we get L over F divides K over F equal to L over K. Thus we get K over F will divide L over F. Thank you.